All right, let's just do this. Hopefully this starts. We've had trouble with the slideshow. But yeah, like I said, for today's class, it's gonna be very simple. It's mostly just to go over the basics of the layout and make sure that you meet everyone, which we've already done. The Wi-Fi they posted here is Grace Hopper, but I think that one also works. We've had quite a few networks going around, so just try either one of these two and pick the one that works best for you. Cool. All right. Okay, so I've introduced me and Sean. So Sean currently works. All right, Sean, do you want to introduce yourself?
Sure, yeah. So as you already know, I'm from Chicago originally. Live in Brooklyn now. Currently work for Bloomberg as a software developer. I went through the immersive program. I graduated in June from the immersive program, and then I was selected to be a fellow, just like our fellows in the back. So I worked as a fellow for 3 months here at Full Stack as well. Yeah, I wrote my first line of code in JavaScript like a year and 8 months ago. So I did exactly what you are doing right now very recently, and then I got into this program, and it just accelerated my career forward. So I totally, I know the struggle. I'm here to help you through it. So yeah, really looking forward to the course.
Cool. And I'm David. I also work as a software developer at a small startup called Simon Data. Like Sean, I was also a graduate of the full stack curriculum here. And then I went to, I was also a fellow. And so, yeah, so Sean and I both come from the full stack program. So we know very well kind of where you're at right now and what you're going to be going through. And it's our job to kind of help you navigate it. And so if you have any questions about anything at all about this process, definitely let us know. Okay. Okay, cool. So the basics of the course. This is a 4-week long course, and we'll be meeting every Monday through Thursday, from 6:40 to 9:40 every night. The start time. So there's a class in here before us that should end at 6:30. So usually people come around 6:25, 6:30 ish, and they hang out in the common area. If you guys have been there, it's to your right when you got off the elevators. So people usually hang out there until this class wraps up, and as soon as they're done, we come in here and try to start at 6:40. The class is 3 hours long, so we go until 9:40. Although if you do want to stay later and work or talk to us or ask questions, that's definitely fine. But I think the building itself is 24 hours. But there is a cleaning staff that comes in, I think, around 10-ish. So around 10 o'clock, you'll see a lot more activity around here. So, feel free to work a little bit later if you want, but there is a time in which the cleaning staff might ask you to move just because they had to clean the floor. Yeah, and so every class will be covering either a new concept or a series of new concepts in JavaScript. How the class is divided up is for the first hour or so, it'll be a lecture conducted by either me or Sean, kind of going over the background and how to use that particular concept or that series of concepts. And we'll go through some live examples together as a class. I'm so sorry for this drilling noise right now. I know it makes it hard to hear. Can everyone hear me all right? Even the ones in the back? Okay, cool. And then the second half to 2/3 of the class actually will be you guys pair programming. And we'll cover a little bit more on what pair programming means in one of the next coming up slides. Cool. So this is the current course schedule. All of these slides will be shared to you guys via the full stack platform. And we can talk about more of that, but no need to memorize this by any means. But this is kind of very rough outline on the topics we'll be covering and the pace in which we'll be covering them. Obviously, if one of these does go over, or if we want to do an extra review on any of these, feel free to let us know. We're always happy to work more on it. But this is the general layout. I'm just going to turn on the lights so you can see the sounds better. Cool. Cool. All right, so just a little more background about the course, right? So has everyone here completed the JavaScript Jumpstart program? Ever has? Okay, cool. And it's really important because a lot of the things that they teach you in that Jumpstart program are the very bare fundamentals that you need to get started in JavaScript. And so if you don't have a good grasp of that, when we start talking about these concepts, some of them may seem very foreign to you. And so really, it's more for us to make sure that you get the most out of your experience in your 4 weeks here. So that's why we really strongly encourage everyone to complete that and also to feel like they're very comfortable with the content inside of it. During this first week, you may feel like there may be some overlap between what we're teaching you guys versus what you did in Jumpstart, right? And part of that is very intentional. Everyone, completes Jumpstart, but we want to make sure that everyone actually truly understands the fundamentals of what's going on, because everything else that we learn in the subsequent weeks will be built up upon what was upon what's in Jumpstart. So if you don't have a comfortable grasp of that, we want to make sure you have that before we move on into more advanced concepts. Once again, because everyone is very much starting off learning JavaScript here, ask us anything, right? Like we want to be as much of a resource for you as possible, and really like no question is too silly at this point, right? Everyone's just getting started, so we encourage you guys to be as open and transparent and to ask as many questions as you can, because obviously in the class of 20 people, more than one of you will most likely have the same questions too. So why JavaScript? So JavaScript is actually the most popular programming language in the world. It's something that I think the latest Stack Overflow. I actually think the 2017 Stack Overflow survey came out pretty recently too, and JavaScript is still the most common programming language in the world. And one of the reasons why it is so common, or one of the reasons why it proliferated so much, was because JavaScript is able to be run in your browsers, right? And so what I mean when I say a browser, things like Chrome or Firefox or Internet Explorer or Safari, right? All of these are portals that lets you access the internet. But if I try to run Python or Ruby or any other language in a browser, it won't work, right? The browser doesn't know how to read or how to run that language, but it does know how to run JavaScript. And so because the web is everywhere and now more and more technology is being built on web applications, JavaScript is becoming more and more important. The other part of JavaScript is that running it on the browser is great, but as of maybe like about 8 or 9 years ago, something called Node came out, Node.de, and I'm sure if you may have heard of it if you've done any research on JavaScript. But the really cool thing about Node was that in addition to letting you run JavaScript in your browser, so what we call the front end, Node also lets you execute and run JavaScript on the back end, so on your servers. So what that means is that for the first time, you can develop an entire app using only one language, right? In your servers, you're using JavaScript to run all of that. And on the front end, what the user sees, where you're engaging with the user on, you can also use JavaScript. I know right now the idea of front end and back end may be a bit confusing. And as we go through the course, you'll see more and more examples of the delineation between the two. But just know that JavaScript right now is an insanely popular language. And one of the biggest reasons for its appeal is that it can be run on both the front end and the back end. And you can basically build an entire application using only JavaScript, which is something that very, very, very few other languages offer. Sorry, for sure. Yeah. So basically it's very user friendly and it's very relatively easy to learn. Paired programming. So when we say paired programming, and that's the second half of every class, what we mean is that every single class will be randomly assigning you to a partner. Sometimes you might work in groups of threes, but the concepts are going to be, like most of this is going to hold, right? So why pair programming, or rather, why would we want you guys to be able to work with other people when you program? When most people think of developers, right, they think of someone in front of a computer by themselves, probably ingesting large amounts of caffeine and writing a lot of code, right? Why are we telling you guys that it's very important for you to pair program? Any ideas? In the back, yes. Can I see? Right, yeah. So one main reason is we want someone else to be able to see what you're writing. One of the most common things in programming is that it's one of the most common kind of pitfalls is that it's very easy to get lost in your code, right? Like you look at one problem and you don't know how to solve it, and then you realize it's caused by another problem, and then you realize that's being caused by another problem, and so on and so on. And so it's actually very easy in programming to fall into these rabbit holes of kind of more and more deeper problems. And sometimes it actually helps a lot to have someone else be there for you to say, hey, rather than trying to solve this particular problem, which is also spawning 8 other problems, let's try this some other way. Or is there a better way for us to do this? So having someone else there is definitely having someone else read your code alongside of you is definitely a great way to make sure that you're on track. Any other reasons?
Well, I think it's helpful to talk out loud through some of these concepts or some of just to talk out loud, to verbalize some of the things that you're working on.
Yeah.
And also, like as an instructor, I think teaching somebody, you start to know intimately what you're working on.
Yeah, absolutely. Yeah. So as you go forward in your programming career, and Sean can vouch for this too, right? Very rarely is someone going to hire you and you'll be the only developer working on one thing from scratch. More likely than not, you're going to have a big team with a big code base, right? And so really, engineering cooperation is actually extremely important because if you start at a new job or a new company, more likely than not, all the other developers there know more than you at that point, right? So you need to be able to not only understand code yourself, but really it's super important for you to be able to communicate about code with other people. And it may sound very trivial, but I guarantee you, from firsthand experience, that it's not. Being able to talk with other people about what you're doing and explain to them how you're thinking about a problem and understanding how someone else is thinking about a problem is vastly, vastly important. And so when we're paired programming, one of the features that we emphasize is that only one person is typing at any given time, and one person is reading the code. So and then once you guys reach a good point, you guys can switch off, and the other person can type, and the other person can drive. We call it one person driving, one person passenger. So whoever's driving is who's typing, and the passenger is the person who's watching the person driving. But we really strongly encourage for only one person to be typing at any given time, is because we don't want to fall into this pattern of two people kind of working heads down independently on the same problem without any communication, because it's just like you just really get so much more out of the programming experience when you have a partner that you have an open channel of communication with. All right, some tips for getting the most out of this course. I'll just kind of go through this all at once. So when we go through this course, we're going to have these workshops. Are going to have a few problems every day. You may or may not finish these problems. These problems are designed to be challenging enough that they should take up the rest of the class for you, and possibly some more time as well. So in order to get the most out of it, we want you guys to not only do these problems, but to be able to very thoroughly understand them. And in programming, sometimes what that means is you have to redo the same problems over and over again until you conceptually understand why it works, or why it does what it's supposed to be doing. In addition, over the course of the class, we'll also have a few optional bigger scale projects for you as well. And these are completely optional, but we think these are projects are good for you to kind of get your hands dirty in terms of trying bigger things and doing things more independently. And once you do these projects, we'll talk more about them when we kind of release them to you. But feel free to send them to me and Sean and your fellows, and we'll be happy to go through this and do a code review for you. So we can say, for this solution, this works, this doesn't work, and here are some tips on how to write better code. And so when we say do all the things, really everything that you do, every bit of practice you get is to your own benefit. So doing as much as possible, is the best way to learn. And programming is one of those things that you really have to learn by doing. You can read a book, you can look at my slides, we can walk through on the whiteboard together and make perfect sense. But as soon as you get in front of a keyboard, like all of that may fall completely apart if you don't practice, or at least get your hands on the actual code itself. Finally, for number 3 is don't be a perfectionist. What that really means is in programming, it's very, very easy to get caught in certain kind of like, well, what about this scenario? What about this scenario? How do I make this, look the exact way that I want it to, right? So coding, it's always a balance between what's practical and what's, I guess, in some ways, what's beautiful, right? Code, like anything, code, I guess, especially, can be iterated upon over and over again. You can write something that works, but you can always write something better that works. And so what all number 3 is trying to say to you is really focus on understanding the big concepts, right? If you write if we're trying to teach you, for example, recursion as one principle, right? And you write a method that does it really well, or that does it, and you're like, okay, I understand what this function does. I understand what this recursive function is doing. Don't spend the rest of the time trying to make the syntax look very pretty, or doing this or that, or things that don't really help you understand the concept of the code. The most important thing in this curriculum really is for you to understand these overarching JavaScript concepts. And so that's what we mean when we say don't be a perfectionist. It's don't kill yourself sometimes on small details. Rather, focus on the bigger picture and focus on understanding the root concept that we're trying to teach through these workshops. And then just do the problems over and over again until you feel very comfortable with them, because more likely than not, any concepts or any problems we teach you here, you will see later again, whether it be in this curriculum or the bootcamp curriculum, etc. Cool. Okay. Because you are going to be working with partners, right? Every day you're going to have someone there who can offer you feedback on your code. And really the big value of pair programming is being able to get that real lifetime feedback. Sean and I are also here as well, but realize that also, whenever you write some code and me and Sean are taking a look at it, or even the fellows are taking a look at it, we're looking at it from scratch, right? Like we're trying to really quickly understand what you're trying to do and how it's being done. whereas your partner's been there for the entire development process. They've seen, how this gone from a blank piece of paper to what's on the screen. So, in addition to us, your partner can also offer you very good feedback on what the development process was like and what are things that you can do to improve upon as well. So the instructors and the fellows are all here for your benefit, but also your partner can also be a very valuable source of feedback for you as well. And then after the workshop is over, we have a Slack channel. I think everyone's on it. If not, we'll handle that logistics part of it in a little bit. But at the end of every class, we'll be slacking out two things. We'll be slacking out a YouTube video, which is this lecture recorded. Obviously, we don't have a camera, so it's just going to be my screen and the slides. So you have a YouTube link, so you can rewatch the lecture if you want. And then secondly is we'll also open up the solutions for you for the workshops that you were doing over the course of that day. So if you finish, you can go back and double check to see if the provided solution or if the solution that we provided you, does what you think it did, and compare your solution to that. Or if you weren't able to figure it out, you can maybe take a step back and look at how the solution did it and try to reverse engineer yourself so that you can get to a point where you understand what's going on. Coding can be very, very frustrating, and especially when you're starting off, there's going to be a lot of walls that you hit. It's inevitable. It really is inevitable. Sean said it. I've hit it. It's very difficult sometimes to reason through what's going on, especially when you're just starting off. And so one of the things you'll hear us talk about a lot, really kind of preach a lot about, is the productive struggle. And what that means is that when you hit a wall, the first inclination is okay, I don't know what's going on. Let me ask somebody to see if they know what's going on. However, one of the core tenets of being a good developer or being a good programmer is being able to figure out what the problem is and try to diagnose it or treat it yourself. Right? Imagine if you were working, in a job on a team, right? If every time you don't know the answer, which is going to be often, and you have to go ask somebody else, it takes away from your learning experience and also takes away from them as well. So part of being a programmer is to be able to see what's happening, being able to identify what the error is, and then critically thinking and trying to figure out, okay, what's causing this error and how far back can I take it just to solve it. And so you'll get this more over the next few weeks, but really coding, especially in the early phases, are going to be a really tough struggle. And so we really encourage you to be able to just try and figure it out yourself. It's not because we don't want to help you. It's not because we don't want to give you the answer. But you'll learn a lot from just trying to figure out yourself and even trying a bunch of things that don't work. Trying things that don't work actually is very fundamental to programming because it really helps you understand what's going on underneath the hood or what's happening behind the scenes. And so if you do ask me or Sean or any of the fellows for help, one of the first things we'll probably ask you is, great, one is what's the problem here? And two, the next thing we're going to ask you is, what have you already tried? Right? And if you say, well, we haven't tried anything yet, we just came across this error, then we're going to say, okay, well, let's try to figure out what the error is and try a few things. And we'll let you, we want you guys to take the time to just try it yourself. And I want to reiterate, that's not because we're being mean or not trying to be helpful. It's because trying to figure out what's wrong is a core facet of programming. It's something that every developer has to have in their toolkit. Yep. Okay. One thing you might hear about is this conflict between ES5 and ES6. What that means is ES stands for ECMAScript, which is essentially this JavaScript standard, right? So when I say JavaScript as a language, who maintains that, right? How do I know that what I'm writing is JavaScript? Who makes sure that JavaScript does what it does, etc.? Who lays out the ground rules for what JavaScript is supposed to be? And there's an organization that does that, and they publish a set of standards called ECMAScript, right? JavaScript, like every programming language, is always developing. People are always adding new features to it. They're always making it better in some way. So ECMAScript 5 is probably the most widely accepted version of JavaScript right now. It was published, I think, a few years ago. But really, when we say ES5, all we're talking about is this kind of older base level of JavaScript. ECMAScript 6 is a newer version of JavaScript that was released about a year ago. And so the difference between ES5 and ES6 is something that we'll cover in the last week of the class. It's really some syntax nuances. and also some new ways to write functions. But for the most part, don't get too caught up in that, right? The core concepts that we're trying to teach you exist in both ES5 and ES6, but because ES5 is most likely what you'll be seeing across the board, and because ES5, anything you write in ES5 will be accepted in ES6, we're teaching you guys ES5 right now. So we're just teaching you a base level of JavaScript that is more universally accepted at this point. Okay? Cool. Oh, sorry. Cool. Okay. So any questions so far on the basis of the class and like the course curriculum or anything I've covered so far? Yes.
Where were these slides going to be again? You're going to put it via Slack?
You're right. Yeah. So on the Slack, I'll have the video and also open the solutions to you. After this, we'll do a quick round of housekeeping where we make sure that one, everyone's on the Slack channel, and two, everyone has access to the Learn.FullStackAcademy platform. Does everyone have access to that right now? Learn.FullStackAcademy.com, I think is the URL.
The jump start.
Right. Cool. Everyone has access. Okay, good. Yeah. So basically, when I say I release the solutions, during the class when you go to the workshops, it will just be the problem. After I release it, if you go back there, it will be workshop and then solution beneath it, so you'll be able to see it. Yeah, we'll walk you through the first few times so you know exactly where everything is. Okay, cool. So for this first class, we're going to start off with something very simple and relatively important, but also very fundamental, which is to write good, clean code. As I mentioned earlier, software, very few people do it single-handedly, and usually what you have is year over years of large development teams building something, right, and iterating over the previous team's work over and over and over again. And so really one of the kind of concepts or one of the sayings in programming is that when you write code, you're actually not writing it for yourself. You're writing it for the developers who are going to come after you and have to look at your code, figure out what's going on, and have to update it and change it, right? And so for that reason, so for your own benefit, as well as for the benefit of the people coming after you, it's super important to write good, clean, tidy code. And what we mean by that is there are a few syntax and conventions that you have to follow. One of the reasons why sometimes code isn't tidy, especially in JavaScript, is because in JavaScript, sometimes untidy code will still run. It will still work, right? If you space things weirdly or differently, it will still run. Right? If you call a variable with some weird numbers and characters, it might also be perfectly valid. But what it does is it makes it harder for people coming after you to understand what's going on. And so while writing tidy code is somewhat optional in a purely programming code execution terms, it actually is actually very important. And so for today, we're going to go over some of the concepts of what it means to write good, clean code. Okay, so the three things we're going to cover are indentation, using camel case and good variable names, and also how to write comments on your code. Okay, so indentation. So you guys should all be familiar with these curly braces, right? Can anyone tell me what the curly braces do? Or rather, where do you most often see these curly braces? Alice?
You see them before and after functions or for loops or if statements to, I guess, maybe they've been paragraphs, so they're like, they make one snippet of code specific to just that one section.
Right, exactly, yeah. So the two main places are just loops and functions, right? And what is that, when you see that curly brace, what is it telling you exactly?
Where it starts and where it ends.
Exactly. So if I see a curly brace and I see 5 lines of code in the middle, and I see an if before it, this just means that all of this code is going to be executed within that if, right? So it really tells you, okay, for this block of code in this brace, you know, kind of what's calling it, or who does it belong to, or where or when is it being run. Okay, and so one of the conventions in JavaScript we say is, okay, if you want to make a function scope, or sorry, not function, if we want to define, you know, an if loop here or a function here. So for example, in line 4 here, can everyone see this slide? In line 4 here, we have this thing, right? It's a for loop, right? Very simple. We're saying, all right, iterate over this array, right? Very straightforward. And we're saying for every element in the array, do what? Do everything here between line 5 to line 10, right? And how do I know that everything from line 5 to line 10 applies to me? Because it's followed by an opening curly brace, and it's on line 11 is closed by the closing curly brace, right? How these work is that these kind of close, the curly braces open and close in sequence. So if I have an open curly brace here, I go down, I see another open curly brace here. This is all still part of the first curly brace, right? When I get down to line 9, I see my first closing curly brace, but this closing curly brace is going to close the opening brace that's closest to it, which in this case is in line 6, right? And so when we actually look at this code, we see that, oh, line 7 and line 8 are in this first batch of curly braces, which belong to this if statement, right? And then we get down to line 11, we see that codes in line 5 through line 10 belong to this pair of curly braces because these close off one another, and these belong to the for loop. Okay. When I say why, sometimes indentation and spacing may be weird, is that I could actually not indent any of this, right? I could have this all lined up perfectly along this for loop, and this code will actually execute perfectly fine, right? So it will work. The JavaScript is not going to tell you, hey, this is not right, or you're doing something wrong here. It will actually execute it for you exactly the way you want it to. But the only problem is, if someone else was to come and look at this code, it's not very clear exactly where this block starts and where this block finishes. So the common convention in JavaScript is after you have a curly brace, always indent everything after that by one tab, and the tabs add up. So here I have a for loop. I'm going to indent everything by one tab or one space, right? And then here I have another curly brace. So I'm going to indent everything in here one more tab or one more space on top of what the tab already was. And so that's why when you look at a lot of code, you kind of see this diagonal cascading effect. And it's because people are just declaring things inside of things inside of things. And when your code is properly indented, it makes it really easy for the reader to figure out where this code block starts and where it finishes. Any questions on indentation spacing? Yes.
Does it matter if you use a tab or a space, or is it preference?
It doesn't matter too much, but the only thing I would recommend is you be consistent throughout the entire course of the code. You don't want to use like one tab and two spaces here or somewhere else. A bunch of there are these holy wars being fought by developers on teams over what's better, tabs or spaces, different editors and don't get too bogged down in that. Just pick one and be consistent with it. It's probably the most important thing. Or if you join a team, they'll tell you what they need you to use.
Do you have a preference?
Yes, but it doesn't matter.
Aren't there programs, if you're writing code, it automatically recognizes that you've opened the curly brace and then it just tabs for you?
Right, yeah. So some editors do tab automatically for you, and if they do that, that's great. But a lot of times, especially when you're kind of going back and changing code, they don't automatically always keep it pushed to the right for you. So you might be indented once, and you might delete one line and not everything has shifted back. So it's always good to kind of go through the code yourself and just make sure that everything reads how you think it should be read. Okay. The other thing is also kind of goes hand in hand with that is that it's fine, but it's really bad convention to just write a curly brace, write code, and close a curly brace all in one line. It will work. The code will execute, but it's just really bad convention. And so usually what happens is as soon as you open a brace, go to the next line, tab it, and then start writing what it was that you were going to write, right? So in general, we never really want to see the curly brace and the statements kind of all on the same line. It might look neat in some cases, but it's bad convention. And as your functions get more and more complicated, you realize that makes things really hairy really quickly. All right, descriptive naming. So variables are what we use to kind of capture data so we can use it in different places, right? One of the biggest things about variable naming, or one of the poorest things you can do with variable naming is to do what they're doing in line 6 over there, and just using one letter. And the reason why is because if you think about a really, really big piece of code, right, it could be several hundred or several thousand lines. If you have a variable called x, or a variable called I, or a variable called something else, and it's just one letter with no context of where it is or where it came from, someone who's reading your code literally has no idea what that variable is referring to, and they have to trace through your entire code to figure out where it came from and what it does. And really, it's just a really bad practice, right? If you have the option of naming something very verbosely or being very clear about it, we always encourage you to do it. Obviously, there is going to be a line between overkill, and we leave it to your best judgment to figure out what that is. But if I was to read the name of a variable, at the very least, I should be able to tell you, okay, I think this is what data this variable is trying to represent or trying to capture, right? So in this case, we have var d equals this date, which tells us absolutely nothing. I can look at that string and say, okay, it's probably a date, but I know nothing about it. And if I was to use this anywhere else in any other function or in any other part of this piece of code, if I just saw D somewhere, I have no idea. However, if I call it birthday and I use it somewhere else, no matter where I see this variable, I can at least have this internal knowledge of, okay, this is going to be a date and it's going to be most likely the user's birthday, right? So using descriptive variable names helps you, especially when you write a long piece of code, as you go through trying to figure out what's happening at each stage. It really makes it a lot easier for you to figure out. It makes it a lot easier for you to figure out, what's doing what and which variables are being used at any moment. The other thing about variable naming is JavaScript has something they use called camel case. And once again, everything I'm talking about here is in JavaScript, right? If you look or dabble in any other languages, they're going to have different rules, different syntax, and different conventions. So what I'm saying here is purely for JavaScript. JavaScript uses something called camel case, which, as the name indicates, right, what it means is if you have a variable that's just one word like birthday, everything's lowercased, right? But if I say, hey, when is someone's first birthday, right? If I have a variable called first birthday, because it's two words, you leave the first word's first letter lowercase, but you capitalize the first letter of every word after that so that someone can read it and they know that these are distinct words, but they're one variable name, right? Kind of like how the word camel case here is capitalized in itself. In this case, it's two words, and the first C of the first word is lowercase, but we know that this case is going to be a second word, so we're going to capitalize it so that when someone reads through it, it's very clear where the delineation is and what are the words they're trying to capture in this variable naming. Okay. There are a few cases in which using very short-term variables is fine, and we'll cover that when we talk about loops. But usually it's for when we're inside of a loop and we're doing counter. And the reason why it's okay in those instances is because in most cases, loops generally tend to be very short, and so you can kind of very quickly keep track of what's going on. And the other thing is because oftentimes once we're out of that loop, once we're done with that loop, we toss away the counter. Like we don't need to use it anymore, right? So it's not like we need to keep this variable that we can use in a bunch of different places. Usually for a counter, we're using it purely for the purposes of trying to figure out where we are in the loop. And once we're done with that loop, we're done. However, if your loop is very large or if you're doing a lot of multiple things, it's perfectly fine to have a long or more verbose name for the counter. It's just conventionally people do use, usually for loops you'll see people use I for increment, but yeah, or sorry for index, sorry. But you can use more verbose names in other cases as well. Any questions on the naming, variable naming? Everyone's good? Cool. All right. And then the last part, and this is something that's very, very kind of, this is something that's very subjective to what you want and kind of your style as a programmer, right? And that's just writing comments. So writing comments does quite a few things, some of which I personally didn't realize until I started kind of working in a live environment, right? So, well, comments can be thought about some ways, right? Comments at a high level can tell you the overarching purpose of a huge block of code, right? But comments can also be used on a very micro level to make comments about a certain piece of code, right? For example, you might be able to say, hey, this code beneath does this. You put in X and you get out Y, right? You put in a number and you get out a Boolean. Or you put in a bunch of numbers and you get out an array, right? So it could be very clear. I'm trying to explain to you what that piece of code is doing. The comment could also be a warning, right? Saying, hey, this does this, but please don't use it for this. So it's almost like you're leaving like notes for future developers or even yourself when you come back and revisit code. It's like, oh yeah, use this for all numbers except for 0, right? Or do this, but be careful because down the road this is going to happen, right? So it's another way for you to leave notes about what to do. You can also use it to make notes to make comments around something along the lines of, this is currently doing this, but down the road we'll need to make this better, right? So leaving to dos for future developers so they understand what it's doing now and what the current limitations are and how they can improve upon it down the road. Comments can be as long as or as short as you want. Obviously, don't spend all of your time writing comments. That's kind of like the number 3. Don't be a perfectionist. Like, you can definitely overkill on comments. But if I was to read someone's code and there's 0 comments at all, I'm really just starting from scratch and it's really hard to read it. Whereas if someone has code that's very clearly labeled and commented out, I can at least start to segment it and partition it more correctly. And I think as you guys do more pair programming and as you work on other people's code, you'll begin to realize that everyone does think very, very differently, especially when it comes to programming. And so having comments is very valuable for you to understand other people's code, and hopefully that will make you also more aware of writing comments yourself when you write code. And then lastly, comments can take either just a single line, in which case the syntax is just 2 backslashes, or if you're going to write a multi-line comment, you can do a backslash and an asterisk, and then to close it off, you close it off with another asterisk and backslash, and this can take as many lines as you possibly need, right? It's for you to write bigger blocks of code. So in my experience, how this looks is, if I have a big function, right, or a big class, usually you'll have this like a multi-line code at the very top of the function saying, this function takes in this, and it spits out this, and this is when or how you should be using it, right? So before someone even dives into the code itself, they have a good sense of what this big block of code is doing. And whereas the single line comments are for more shorter notes, like, oh yeah, this variable, should be used in this case, or this is just a placeholder we're using for something else. Okay, but writing comments is very important to make sure other people understand what's going on, and for you to be able to kind of keep track of what's going on in your own mind as well. Okay, as you go through this, it's inevitable that you're going to be writing buggy code. And by buggy code, what I mean is you're going to be writing code that does not do what you think it does, or it doesn't do what you were expecting it to do. And the clearer your code is, with good variable naming, with good indentation, and I guess because you're looking at it yourself, possibly good comments, but like the cleaner all 3 of those things are, you will have a significantly much easier time debugging and trying to figure out what went wrong and how to fix it. Just from personal experience, I remember during the last bootcamp class, when some of the students submitted the optional projects that they did, right? One of them was a Sudoku validator, and so I got the code and everything was spaced like kind of very weirdly in this random spaces. It's clear they were working on it, but they were also kind of going back and deleting chunks and not make sure everything looks clean. So I actually just spent the first like 5 minutes just like re-indenting everything and making sure all the variables names line up, so that at least when I start reading it, I'm not hung up by, wait, why is there like a 5-line difference, or which block does this line of code belong to? Is it the if statement? Is it the one above it, et cetera, et cetera? So like, it's one of those things where you're gonna get to a point in which like when you go and look at like poorly indented code, like you're gonna want to do it yourself because it just helps you understand it so much better. So yeah, good code is imperative for debugging and fixing things. Obviously, the sooner you write cleaner code, the easier time you'll have. And then the last thing is in some browsers, and this is very optional depending on if you want to code in a browser, if you want to code in something called REPL, if you have if you have an IDE, so like a Sublime or like a text editor of some sort that you write code in. Some of them does do some of the spacing and some of the naming and the stuff for you. So I guess for this third bullet point, what I would say is, feel free to experiment on your own, trying to figure out what works best for you. But just make sure that even when the software is doing a lot of the spacing, a lot of the indenting, a lot of the other stuff for you, like don't take it for granted that's always correct, especially when you're going back and editing code you've already written, because the computer has no concept of redoing this from scratch the way that you do. Okay, I think that should be it. So any questions so far on the on the slides? Yes, Jim.
Do you recommend not using like an IDE or anything like that to just get the syntax like so you don't put yourself in any bad habits?
I don't have a preference, and the reason why I don't is just because at some point you're going to be using IDE regardless. So like it might be better for you to kind of get one that you're comfortable with. I think it's a lot more important that you understand what's going on behind the scenes, right? So like for example, one thing that that I use, I think Sean uses too, when we write code on the boards, we use something called REPL, REPL.it. It's like a site that you can select the language you want to start typing code, it'll execute it for you in the browser. So like that could be like your IDE of choice, right? And if that's what you want to type code in, that's perfectly fine. Just understand what they're doing and understand what the best practices there are. So if you want to use Sublime or another text editor, feel free to. There's a ton out there. Like literally, like there's so many choices. I think Atom's another one that a lot of people like to use as well, or Vim. But no matter which one you pick, as long as you're comfortable with how to use it, like that's by far the most important thing. Any other questions? Cool. So we have about 35-ish minutes left. So what we're gonna do is we're gonna take a quick bathroom breaks, and I'll make pairs, and I will stack up the pairs, and then I will open the first workshop for you today, which is all about kind of writing good, clean code. And what you're gonna get is you're gonna get some really bad, messy code, and your job is to go back through and fix it. So feel free to go to the bathroom, take a break. I will stack out the pairs on the Slack. Is everyone by the way, is everyone on the Slack channel? Okay. The name of the channel is let me find it really quick.